Hi, my name is Manasseh Ephraim. Um, in this video we will be doing an example of a trigonometric substitution. In the previous two videos I did a thorough introduction of trig substitution. I only did one example, but the introductions are very useful. So I suggest that you watch those two videos before or after you watch this one, because they're very interesting and thorough introduction. Now, to integrate this expression, what we will be focusing on for now, the first step is to focus on, we look at this expression under the square root, and we use a trig substitution to simplify this square root so we get an integrable expression. And the trig identity that we'll be using is one of those trig identities, and you can see that x squared minus 25 kind of resembles sec squared theta minus 1. If I have an x somewhat the second theta, then I can simplify the 25 and be able to use this trig identity. So now let's let x be 5 secant of theta. Well, then dx becomes 5 sec theta tan theta d theta. Okay, also x squared minus 25 becomes 25 sec squared theta, that's x squared, x is 5 sec theta, minus 25, which is 25 times sec squared theta minus 1. And that's why I had the 5 here. That's why I had the 5 here, so I can factor out the 25 and get some expression that looks like this, the secant squared theta minus 1. But secant squared theta minus 1 is tangent squared theta, so I have 25 tangent squared theta. Well, that tells us that the square root of x squared minus 25 becomes the square root of 25 tangent squared theta, which is 5 tan theta for theta in the first quadrant for appropriate values of theta. Okay, we'll be taking theta in the first quadrant in this case, so that tan squared theta, the square root of that, becomes tangent of theta. Now, so the integration now becomes, the integral becomes dx, which is now 5 sec theta tangent theta d theta, excuse me, divided by x squared, which is 25 secant squared theta, that's because x is 5 sec theta, times square root of x squared minus 25, which is 5 tangent theta. Okay, that gives us, you cross out tangent theta and cross one of the secants, and if you cross this 5 out, that gives me 1 over 25. It's a constant, so I can take it out of the integration sign. 1 over 25 times the integral of d theta over secant of theta, or it's 1 over 25 times the integral of cosine theta d theta, because 1 over sec theta is cos theta, and that gives me 1 over 25 sine theta plus c. Well, so I have sine theta. What I need is something in terms of x. I have something in terms of sine, in terms of theta. So I'll be converting 1 over 25 sine theta into expressions of x. So here's how we do that. Okay, remember x was 5 secant of theta, which means that secant of theta is x over 5. Okay, so if I make a triangle and call this angle theta, okay, right angle triangle, how should I label this triangle so that sec theta equals x over 5? Remember, sec theta is 1 over cosine theta. Cosine theta is adjacent over hypotenuse. So this, if I label this as 5 and this as x, then cos theta will be 5 over x, or sec theta will be x over 5. Now I'm going to calculate this guy, this side. Okay, well, let's call it a for now. So a squared plus 5 squared should equal x squared. That's Pythagorean's theorem. Or a squared should be x squared minus 25, or a is the square root of x squared minus 25. So this triangle will have this side equals the square root of x squared minus 25. Okay, so now what did we need? We needed sine theta. Sine theta now is opposite over hypotenuse. Okay, so therefore the integral of dx over x squared times the square root of x squared minus 25 now becomes 1 over 25 times the square root of x squared minus 25 over x plus c, or you can simplify it as, not simplify, but rewrite it as x squared minus 25 over 25x plus c, and that's the integral. So this is an example of the trig substitution. I took this problem from a textbook, from a calculus textbook by Rogowski. That's question number 16 of page 447 in the textbook. It's a nice and excellent book, has a good examples. That's a good reference book to use. Thank you and goodbye.